Hello, this lesson is on the mole and representative particles. So a mole is a unit of measure for some amount of a substance. You can't always measure in grams or liters in chemistry, so we're going to use this mole as a middle ground unit. A mole is going to represent 6.02 times 10 to the 23rd representative particles of whatever substance you're referring to. This is called Avogadro's number. So a representative particle is going to be the species that is present in a substance. So this is going to vary. It can be an atom, an ion, a molecule for our covalent compounds, or a formula unit for our ionic compounds. Okay, so here we have a little chart that we're going to go through and fill in. I can get this out of the way for us. Alright, so our first substance is atomic nitrogen. Now, atomic nitrogen is going to be what type of particle? An atom, an ion, a molecule, or formula unit. This guy is an atom. And how do we write an atom of nitrogen? Well, we simply write an N. And how many atoms of nitrogen will there be in 1 mole of nitrogen? There's going to be 6.02 times 10 to the 23rd atoms of nitrogen in 1 mole. Now we have nitrogen gas. Nitrogen gas, is it an atom, an ion, a molecule, or a formula unit? This is a molecule. And how do we write nitrogen gas? Nitrogen is one of the 7 diatomics, so it is in 2. If we had a mole of nitrogen gas, how many of these molecules would be there? Avogadro's number, 6.02 times 10 to the 23rd. Next up is water. Is water an atom, an ion, a molecule, or a formula unit? It is a molecule. And what is the formula for water? H2O. So if you have 1 mole of water, how many molecules of water are going to be there? Avogadro's number, 6.02 times 10 to the 23rd. Next up is the calcium ion. Is this an atom, an ion, a molecule, or a formula unit? It is an ion, hence the name calcium ion. And how do we write a calcium ion? Well, calcium is Ca, and it has a 2+ charge. So if you had a container of just calcium ions, how many ions do you think would be there? Avogadro's number is how many you would have. And last up, calcium fluoride. Is this an atom, an ion, a molecule, or a formula unit? Calcium is a metal, fluoride is a nonmetal. That is going to make this an ionic compound. So its particle is going to be a formula unit. And how do we write calcium fluoride? Well, calcium is a 2+ charge, fluoride is a -1 charge, so it's going to be CaF2. And if we had a container of calcium fluoride, a 1 mole container, how many particles would be in that container? How many formula units of calcium fluoride? There would be 6.02 times 10 to the 23rd particles. Sorry about that line. Alright, so for moles to representative particles, since we are starting with a mole and going to a representative particle, when you write a conversion factor, remember that what you want if we want representative particles, we're going to use Avogadro's number. That's going to be in the numerator. And since you already have moles, moles will go in the denominator. So this is going to be however many moles that you have been given. So that's going to come from the problem. And then this is your conversion factor. So since we want representative particles is going to be in the numerator. Since we are trying to get rid of this mole unit, moles has to go in the denominator so that they can cancel out. Now, if you're going in the reverse direction, we're trying to get from representative particles to moles. Okay, we're starting with representative particles, so what's going to be in the numerator of our conversion factor? 1 mole, and in the denominator, it's going to be Avogadro's number, 6.02 times 10 to the 23rd, however many particles you have. So remember, 1 over half. We want moles. So 1 mole is going to go in the numerator, and you're trying to get rid of this representative particles. So the representative particles has to be in the denominator so that they can cancel out. 1 mole is always equal to Avogadro's number of particles. So since these are equal to each other, you can set them in a conversion factor 1 over the other, depending on what you are looking for. So let's look at a couple of examples. First example we have is how many moles of 1.25 times 10 to the 23rd atoms of magnesium is how many moles of magnesium. Sorry about that. So what did they give us in the problem? They gave us 1.25 times 10 to the 23rd atoms. So that's what we've been given. So now we're going to set up our conversion factor. So what we want goes in the numerator, and we are looking for moles, right? How many moles? So we're going to put moles, 1 mole in the numerator, and we are trying to get rid of atoms. So we need to put atoms in the denominator, and that's going to be the Avogadro's number, 6.02 times 10 to the 23rd atoms. So you can see that our atoms units are over top of each other, so they're going to cancel out. We are left with mole, which is what we are looking for. So now you're going to do math. Remember to use your EE or your EXP or your times 10x key, and don't combine that with another multiplication sign or another 10. It's going to include it all in that one function. So we have 1.25 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Sig figs, you're going to need 3 in this case. So our answer is 0.208 mole. And I want you to go ahead and try this next one on your own. and we will discuss it tomorrow.